Hi there. Today I'm going to show you how to combine compounds using the binary type 1. Let's take a look at this example. We have here a barium and a bromide. Now, the first step you need to do is to find the cation and the anion, which is very simple. Cation is always the metal because they compose the positively charged ion, and on the other hand, the anion, they are always the non-metal because they compose the negatively charged ion. Now, in order for you to combine these two, you just need to put them together, taking the suffix of the non-metal and change it into IED, making you or giving you the answer barium bromide. Now, when it comes in the formulating this compound, you just need to find their symbol and their charges. Now, take a look at this example. We have here the symbol for barium, which is Ba, and has two positive charges. On the other hand, we have bromine, which is Br and has a one negative charge. In order for you to combine these two, you just need to use the crisscross method, wherein you're just going to put the two positive charge in Br, making it Br sub 2 and Ba sub 1. In other terms, you're just going to say it Ba, and combine them, you're just going to have BaBr sub 2 or barium bromide.
Molybdenum 3 bromide. Since molybdenum is a metal that cannot be found in group 1 or 2, it is considered as type 2 binary compound. So first step, find the oxidation state. As given by the Roman numeral, the oxidation state of molybdenum is positive 3, while bromide has negative 1 based on the periodic table. Second step, find the LCM. So find the least common multiple or LCM of 3 and 1. The answer will be 3. Third step, balance the charges. So we can balance it with the use of our LCM. So you need to divide the LCM by the oxidation states of an element. Molybdenum has positive 3, so 3 divided by 3 is equal to 1. And the next element, bromine, has negative 1, so 3 divided by 1 is equal to 3. So we need 1 atom of molybdenum and 3 atoms of bromine to balance the charges. Fourth step, final, write the symbols and atoms, so the answer will be MOBr3. MOBr3. First step, name the elements. So molybdenum is not in the first or second column of the periodic table, so therefore we needed Roman numeral in naming. Mo is molybdenum and Br is bromine. In naming the second element, find the root and add IDE, so we already have molybdenum bromide. Second step, find the Roman numeral. In order to find the Roman numeral, we need to follow the following steps. 2.1. Find the charge of an ion. Br has negative 1 charge. 2.2. Get the total negative charge. In order to get that, you need to multiply the number of atoms to the negative charge present in an element. So bromine has 3 atoms, multiplied by negative 1 is equal to negative 3. 2.3. Balance the charges. So negative 3 is automatically balanced to positive 3. 2.4. Finding the Roman numeral, divide the total positive charge by the number of atoms in the first element. Molybdenum has only 1 atom, so 3 divided by 1 is equal to 3. Third step, final answer. So the final answer will be molybdenum 3 bromide. Phosphorus bromide. Since both of the elements are nonmetals, this is a covalent compound or type 3. Step 1. Get the symbol of the elements, P for phosphorus, then Br for bromine. Step 2. Look for the prefixes. Prefixes indicates the number of atoms present in the element, so phosphorus automatically have 1, then penta in bromine represents 5 atoms. Step 3. Final answer. Write the symbols and atoms all together, so the answer will be PBr5. In naming elements, since it is a covalent compound, it must include prefixes. Step 1. Name the elements. P is for phosphorus, then Br is for bromine. Step 2. Change the second element's name by getting the root and adding IDE to its end. So bromine plus IDE is bromide. Step 3. Look for atoms. Since P only have 1 atom, we don't need to include mono. And since Br has 5, use the prefix penta. Step 4. Name it. So put all the prefixes before the element. Bromine has 5, so it will be pentabromide. Note, you don't need to put mono in the first element. Step 5. Final. So the final answer will be phosphorus pentabromide.
Ammonium cyanide. In writing a formula, first thing that we need to do is to write the symbol of each ions. That will be ammonium, NH4, and cyanide, Cn. Second, we need to balance the charge that they have. The ammonium has a charge of positive 1, while the cyanide has a charge of negative 1. So they are balanced. To write the compound formula, you just need to write the symbol and you'll have NH4Cn. For naming, we just need to get the ions in the compound, which is ammonium and cyanide. The name of these ions will just be retained and just combined it. And that's all. That's how you write a formula and name a formula.
HClO. Step 1. Identify the ion. HClO contains the ion ClO-, which is known as hypochlorite. Step 2. Use the rules. If you have the ion with the suffix "ide", you're going to replace that with the prefix hydro plus the suffix "ic" and then the word acid. But if you have the ion with the suffix "ate", you're going to replace that with the suffix "ic" plus the word acid. Lastly, if you have ion with suffix "ite", you're going to replace that with the suffix "ous" plus the word acid. Since hypochlorite has the suffix "ite", you're going to replace it with "ous" and then the word acid. So HClO is called hypochlorous acid. Hypochlorous acid. Step 1. In order to convert the name into a chemical formula, we need to focus on the suffix "ous". Step 2. Replace the "ous" with "ite". This gives us the polyatomic ion hypochlorite. Step 3. Using the iron chart below, we need to look for the formula hypochlorite. So hypochlorite has the formula ClO-. Step 4. We need to add hydrogen ions to these polyatomic ions. In order to add hydrogen ions, we need to neutralize the negative 1 charge, so therefore we need to add 1 hydrogen ions. Step 5. We need to write the hydrogen atom first, and so it's going to be HClO.